Hello, welcome to my YouTube channel. My name is Nanye Abraham and I am your mathematics teacher for today. Today we are beginning a new topic and then we are looking at the topic in mathematics called matrices. Matrices. And in this lesson we shall be looking at introduction of matrices. And this topic is a course on its own. It's in this topic we'll be looking at introduction of matrices as a full topic on its own, and this will take us several lessons before we'll be able to finish with the introduction of matrices. So the name again is Nenye Abraham and you are welcome to my YouTube channel. Let me write my name. Please subscribe to my YouTube channel if you haven't. Please subscribe to the YouTube channel. Now we are looking at matrices. First, we want to look at the definition of matrices. Definition of matrices. A rectangular arrangement of mn numbers. Mn numbers in m rows and n columns are enclosed in n columns and enclosed within a bracket is called a matrix. We shall denote matrices by capital letters as A, B, C, etc. Now, the definition is saying that a rectangular arrangement of mn numbers. Now, it just means that numbers are being arranged in a rectangular form. In a rectangular form, it could be square. Square is a type of a rectangle. So, in a rectangular form, it means that before you can call something a matrix, it should be arranged in what? In a rectangular form. It should be arranged in a rectangular form. And then it has rows and columns. It has what? Rows and columns. It has rows and columns. And normally we represent them or we assign them by capital letters. That is A, B, and C. That is what the whole statement is saying. So this is one example of matrix. This is one of the examples of matrix. Now you realize that we have assigned the whole of the matrix here to what? A. To A. And then we said that A1, you have A1, A2, A11, A12, up to what? A1n. So what this implies is that if you pick a matrix, for example, if you pick a matrix, now whatever is in the row, now this moving this side is what we call a row. Moving horizontally is what we call a row, and moving vertically is what we call columns. Now matrices begin from this side, from the first element or entry, which is A. Let's represent it by A. Now A1, if you start from A1 going this side, now this one is what is always talking about what? Row. So A11, this is A11. Now the next item will be A12. The next item will be A13 up to A1n, which means that up to the number of elements you want to enter as what? The rows. Now if you come this side to, it will now be A. Now this side changes. It's, you see that the first item here, which it will now be A21. Now if you start from this place and you are moving towards this place, it will be A21, A22, A22, A23, and then up to A2N. Now you realize that the first number is changing when you are moving towards the column side, that is vertically. When you are moving horizontally, the second number changes. The second number changes. So they said um, A is a matrix of order m by n. Ith row, jth column element of the matrix denoted by Aij. Now, this is just the same as what I was explaining here. It's just the same as what I was explaining here. So, whenever you hear them saying that a matrix is A, I, J, the I stands for the what? Rows, and then J stands for what? Columns. That is why when you are moving towards this place vertically, you see that the rows what increases. When you are moving vertically, you see that the rows what increases. When you are moving horizontally, you see that the columns what increases. So I stands for the row and J stands for what? Columns. A matrix is not just a collection of elements, but every element has assigned a definite position in a particular row and column. So you can just mix them. There is a name to every element in that what? In that matrix. In that matrix. So for example, you can bring A11 to this side. The position has an assigned definite what? The element here has an assigned definite what? Position. So there is one thing I want to mention before we continue with the lesson. Now we have, having been given this matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Now, this matrix is called 3 by 3 matrix. 3 by 3 matrix. And the 3 is from the number of what rows we have, and then the number of columns we have. So we have the rows 1, 2, 3. Then the columns we have 1, 2, 3. So we call it what? 3 by 3 what? Matrix. Now assuming you have a matrix like this, A11, A12, A21, A22. This matrix will be called 2 by 2 matrix. It will be called 2 by 2 matrix because we have two number of rows and two number of what? Columns. We also have a matrix like this, A11, A12, A13, A21, A22, A23. This matrix will be called what? How many number of rows? 1, 2. 1, 2, 3. So it will be what? 2 by 3 matrix. So the row comes first, and then the what? The column comes, or the columns come second. So you say 2 by 3 because the rows are what? 2, and then the columns are what? 3. So we say 2 by 3 what? Matrix. But if you have something like this, A11, A12, A13, sorry, A21, A22, A31, A32. This matrix will be called 3 by 2 matrix. 3 by 2 matrix. So this is just to teach us how to pronounce matrices, or when we are pronouncing it, you wouldn't be confused about what we are saying. We have what? 3 by 3, 2 by 2. You can even have 1 by 2. It's anything. So, but it should be in a rectangular what? Form. It should be in a rectangular form. You learn that in the definition of matrices. They said it is a rectangular arrangement of mn numbers. So it should be in a rectangular what? Form. Now we want to continue by looking at some special types of matrices. Special types of matrices. Types of matrices. We have the first one we want to look at is square matrix. Square matrix, and it says a matrix in which numbers of rows are equal to number of columns is called a square matrix. So when the number of rows are equal to the number of columns, then we say that it is a what? A square matrix. For example, we have what? 3 by 3 matrix. 3 by 3 matrix means that the number of rows is equal to the number of what? Columns. We have 2 by what? 2 matrix. We have what? 5 by what? 5 matrix. These are all square matrix. They are rectangular, but they are square. They are square because the what? The distance, the horizontal distance is equal to the what? The vertical distance. And so we call them what? Square matrices. And this is one example of the square matrices. And it is what? 3 by 3 matrix. This is what? This is 3 by 3 matrix. How many number of rows? 1, 1, 2, 3. How many number of columns? 1, 2, 3. And so we call this matrix square matrices. Now we also have what? Diagonal matrix. Diagonal matrix. Diagonal matrix. And this diagonal matrix, what is the definition? A square matrix A is equal to Aij, or bracket close, n by n is called a diagonal matrix if each of its non-diagonal element is 0. If each of its non-diagonal elements is 0, that is Aij is equal to 0 if I is not equal to j, and at least one element I is not equal to what? 0. So that, please, let's look at this so that you wouldn't be confused about what we are saying here. Now, they are saying that when Aij is equal to 0, if I is equal to, if I is not equal to j, is not equal to j. So I want you to understand that we are looking at diagonal matrix, and what they are saying is that Aij is equal to 0. And I told you from the beginning that I stands for what? Row, and J stands for what? Column. Now Aij is equal to 0 means that the whole of this term, what is the I in this term? The I in this term is 1. The J in this element is also what? 1. If you come to this element, the I in this element is what? 1. The J in this element is what? 2. And then if you come to this element, the I in this element is 1. And then the J in this element is what? 3. Now, you are saying that if I is not equal to what? J, then the whole term should be what? 0. Now, if you look at this term, the I here is equal to what? The J here, which is what? 1, 1. So it makes it what? Not equal to 0. So this will not be equal to 0. These two, if you look at this place, I is not equal to what? J, because I is 1 and J is what? 2. Here to the same thing, I is 1 and J is 3. So they wouldn't be the same. So it will be what? 0. This will be 0. This will be 0. Here, this will be 0. This will be 0. This will be 0. This will be 0. Sorry. Here is not 0. This is not 0. So looking at it too, you understand that the diagonal of every matrix has the I and the J to be equal. The diagonal of every matrix have the I and the J to be equal. So it means that from the definition, what they just want to say is that any matrix whose diagonal alone is not equal to 0 is what we call a diagonal what? Matrix. So you look at this example, you realize that it is only the diagonals that are not what? 0. The rest of the what? The elements in the what? The matrix are all what? Zeros. And so this is what? A diagonal what? Matrix. This is a diagonal matrix. Now the next type of matrix we shall look at is an identity matrix. An identity matrix. A diagonal matrix whose diagonal elements are equal to what? 1 is called identity matrix and donated by IN. So this is what we donate or we represent as an identity matrix. So anywhere you see I, let's say I, it could be IM, I what? IZ. If you see I, a capital I, it means that what? It's an identity what? Matrix. And this is very simple. It is it's just from where we have learned that we've stepped forward. Now they are saying that the diagonals are all 1. So this is an example of the identity matrix. And this is a 3 by 3 matrix. Let's say we have also 2 by 2 to be what? 1, 0, 0, 1. This is what? An identity matrix. This is also an identity matrix who is a 2 by 2 matrix. In this case, it is also what? An identity matrix. It is also an identity matrix. Now let's look at upper triangular matrix. The fourth matrix type of matrix we have what? Upper triangular matrix. Now this one we define it as a square matrix said to be a upper triangular matrix if Aij is equal to 0, if I greater than J. I don't know if I should do the same explanation to this thing because it's the same thing I've always been doing. It's the same thing I've always been doing. So let's use this matrix here. A11, A12, A13 to explain what we have just seen. Now from this you realize that they said aij is equal to 0. That is, we are looking at upper triangular matrix. aij is equals to 0 if I is greater than j. If I is greater than j. So look at it. In this matrix, where do you see I equal greater than j? Do you see I greater than j? Now, if you look at the first one, here they are the same. Here j is greater than I. Here j is greater than I. And if you come to the next row, here I is greater than j. So I is greater than j. Now the next one, they are the same, so it will be there. The next one, j is greater than I. You come to the next row, you see here that I is greater than j. And then here too, I is greater than what? J. But here they are the same, so you won't do anything to them. So you see that this will be 0, this will be 0, this will be 0. So we call this matrix what? Upper triangular matrix. It's in the form of triangle. That is why they call it what? Upper triangular. But that triangle is at the top. So we call this matrix upper triangular matrix. And this is the example. This is it. What I did here. This is it. Then this is the example. This is the example. You see that this is 0, this is 0, this is 0. So we call it what? Upper triangular what? Matrix. Upper triangular matrix. Now let's look at lower triangular matrix. It's the same thing, but just that here when I is less than what? J. When I is less than j, then the what? The aij is what? 0. So looking at it here, you see that it will be like this. I wouldn't waste much time to explain this one. It will be like this. So you see that the top ones will be zeros and the rest will be what? Be like a triangle. It's in the form of a triangle. This is it. It's in the form of a triangle, so they call it what? Lower triangular what? Matrix. Now let's look at symmetric matrix. Symmetric matrix. I think I will, after this one, I will pause here and then continue in the next video with the types. It will still be types, but I'll have to continue in the next video because the minutes is getting so many. So here we have symmetric matrix. A square matrix, A is equal to Aij. This is what I've been explaining. Said to be a symmetric if Aij is equal to Aji for all I and j. For all I and j. For all I and j. So this is also simple. So let me explain this to you. So let me use what I've just written here to do the explanation before I come to the real thing. So what they are saying is that Aij is equal to what? Aji. It's the same thing. So this is Aij. All they are saying is that the upper part of the matrix is equal to, is the same. The elements there is just the same as the elements at the lower part of what? The matrix. At the lower part of the matrix, this is it. The upper part, the three elements at the upper part. If it is a 2 by 2 matrix, it will just be one element. But here it is what? 3 by 3 matrix. So the elements, apart from what? The diagonal at the upper part of the matrix, they are equal. They are just the same as the what? The lower part. So let's look at it. Here, let's use this matrix. You see that this is what? 7. This is also what? 7. So this is what? This is